Hello, statistics students. Here's another video on associations in categorical variables, independent and dependent events. We saw that the probability that a person is married differs depending on whether we know that person is a college grad or that she or he has less than a college or less than a high school education. If we randomly select from different educational levels, we get a different probability of marriage. So the different levels are less than a high school education, the probability they're married is 70 out of 125. The probability that they have a high school education, given that they're married, is 240 out of 397. The probability that they have a college or higher education, given that they're married, is 98 out of 143. These are different. So another way of putting this is to say that marital status and education level are associated. We know they are associated because the conditional probabilities change depending on which educational level we condition on. We call variables or events that are not associated independent events. Independent variables and independent events play a very important role in statistics. Let's first talk about independent events. Two events are independent if knowledge that one event has happened tells you nothing about whether or not the other event has happened. In mathematical notation, A and B are independent events means that the probability of A, given that B has happened, is just equal to the probability of A. Knowing that B happened should not have any effect on the probability of A. It should be the same thing as just the probability of A. In other words, if the event a person is married is independent from a person has a college degree, then the probability that a married person has a college degree, meaning the probability of college given that married, is the same as the probability that any person selected from the sample will have a college degree. So we've found in previous videos that the probability that someone has a college education given that they're married is 0.240. Because given that they're married, that's within the married column out of 408, and the probability that they have college or higher is 98 out of 408, which is 0.240. And then the probability that they're college or higher educated is 143 out of 665 because there were 143 college or higher educated people out of the 665 total, and that gives us 0.215. So one might say these probabilities are so close that we might be willing to conclude that they're close enough. Well, right now we're going to assume they have to be exactly the same. So we might conclude that the events a randomly selected person is married and a randomly selected person is college educated are independent. However, for now, we'll assume that the probabilities have to be exactly the same for us to conclude independence. So we conclude that completing college and being married are not independent. Now, in the formula, it doesn't matter which event you call A and B. So we can say that the statement probability of A given that B is equal to the probability of A can also be written as the probability of B given that A is equal to the probability of B for the test for independence. So key point, to say that two events A and B are independent means the probability that A given B is equal to the probability of A, or vice versa. In words, knowledge that event B occurred does not change the probability of event A occurring. And this concludes the video on associations and categorical variables, independent and dependent events.